Hello viewers, in this session we are going to discuss this important and conceptual definite integral. So we have to evaluate this definite integral. The limits are from minus pi by 4 to pi by 4 and the integrand is mod of cosine x, right? So let us call this integral as I, and here we are going to make use of the concept of sign convention of cosine function in four quadrants, right? And moreover, I will also make use of the definition of modulus function. So let us now first consider the sign convention of cosine function in the four quadrants. So here we have the four quadrants. Here we have 0, here we have pi by 2, here we have pi, then we have 3 pi by 2, and here we have 2 pi. Right now we know that the cosine function is positive in the first and fourth quadrant, and it is negative in the second and third quadrant. So here we have the first quadrant, here we have second, third, and fourth. So cosine function is positive in the first and fourth quadrant, and it is negative in the second and in the third quadrant. So now here the limits of integration vary from minus pi by 4 to pi by 4, right? Now see here we can take say O, and here we can take the point A. So taking these 2 points, that is O and A, and let us consider this ray as the initial site, right? And when we rotate this initial site in anti-clockwise direction, and we form an angle of say pi by 4 like this. Suppose this is our angle pi by 4, right? So here we take the angle as positive pi by 4, because when we measure an angle in anti-clockwise direction, then the angle is taken as a positive, right? So here OA may be taken as the initial side, and when we rotate this initial side in anti-clockwise direction, and here we form the ray say OB, then this angle is taken as positive, right? So here we have plus 45 degrees, and when we rotate this ray OA, which is taken as initial side, in clockwise direction, that is like this, and we form an angle say pi by 4, then this angle is taken as negative pi by 4, that is minus 45 degrees, right? So this side, that is OB, is known as terminal side, and similarly the side here we can take C. So OC is also the terminal side, right? So here we are dealing with the concept of measuring an angle in the anti-clockwise direction and in the clockwise direction. So if we take OA as the initial side, and if we rotate it in anti-clockwise direction, and we form an angle of 45 degrees, then we take this angle as positive pi by 4 or positive 45 degrees. And when we rotate this initial side OA in clockwise direction, and we form an angle of say 45 degrees, then here the sign of this angle is taken as negative pi by 4 or negative 45 degrees, right? So now let us consider the definition of mod function. Now see, mod of p is defined as positive p when p is greater than or equal to 0, and negative p when p is less than 0. And here we have a mod of cosine x. So mod of cosine x can be defined with the help of this definition. So we can now write here positive cosine x when cosine x is greater than or equal to 0. And we have just discussed that cosine x is positive in the first and fourth quadrant, right? That is when x belongs to uh, either the first quadrant or the fourth quadrant, and mod of cosine x is equal to negative cosine x when cosine x is less than 0, and cosine x is less than 0, that is cosine x is negative when x belongs to the second or the third quadrant. So here x belongs to either the third quadrant or the second quadrant. So here we write second quadrant and here we write the third quadrant. So now we have to integrate from minus pi by 4 to pi by 4. Now see, when we go from minus pi by 4 to pi by 4, it implies that we are making a transition from fourth quadrant to the first quadrant, and in the fourth quadrant and in the first quadrant cosine function is positive, right? So when we have to integrate from minus pi by 4 to pi by 4, that is we have to integrate like this. That is we have to go from positive, that is the fourth quadrant in which cosine function is positive, to the first quadrant where cosine function is also positive. So it implies that when x belongs to the interval that is minus pi by 4 to pi by 4, then cosine x is positive, right? That is when we integrate from minus pi by 4 to positive pi by 4, then in both the quadrants cosine x is positive, right? So from the definition of mod function, we can now write mod of cosine x is equal to positive cosine x when cosine x is greater than or equal to 0, and cosine x is greater than or equal to 0 when x belongs to either the first quadrant or the fourth quadrant, right? So now here for mod cosine x, we can now write positive cosine x, and we have the integral I as minus pi by 4 to pi by 4, and here we have positive cosine x, and here we have dx. So now we have a simple integral here, and we know that the integral of cosine theta is equal to sine theta, right? So here we have simply sine x. The integral of cosine x is sine x, and limits of integration are from minus pi by 4 to pi by 4. So now let us substitute the limits and we'll take the difference. So we have first x is equal to pi by 4, and then we have x is equal to negative pi by 4. So here we have sine of minus pi by 4, and from trigonometry we know that sine of minus theta is equal to negative sine theta. So here we have sine pi by 4, and here we can take this negative sign outside due to this result. So here we have positive, and we have sine pi by 4. So sine pi by 4 plus sine pi by 4 is 2 times sine pi by 4, and we know that sine pi by 4 is 1 over square root of 2. So we have 2 over square root of 2. Now we can rationalize here. So we have 2 over root 2 times root 2 over root 2, rationalizing the denominator here. So we have 2 root 2, and here root 2 times root 2 is 2, and 2 get cancelled, and we have square root of 2. So the value of this integral is equal to square root of 2. So viewers, this is how we can easily evaluate this definite integral using these two concepts, that is the sign convention of cosine function in the four quadrants and the definition of mod function. But here we can also evaluate this integral using the properties of definite integrals. That is, we can make use of this property, that is minus a to a, and here we have f of x and dx. And from the properties of definite integrals, we know that this integral is equal to 2 times the integral 0 to a f of x dx, provided this function f of x is an even function, that is f of minus x is equal to f of x, right? So we can first make use of this property to this integral, and then subsequently we can make use of the definition of mod function. Hello viewers, in today's session we are going to discuss this problem from definite integrals. So here we have to evaluate the integral that is from minus pi by 6 to pi by 6, and the integrand is modulus of sine x, right? So let us call this integral as I, and here we are going to make use of some important concepts. And the first one is to make use of this important property of definite integrals, that is the integral minus a to a. And here we have, say, some function f of x dx. Then this integral, that is from minus a to a f of x dx, is equal to 2 times the integral from 0 to a f of x dx, provided this function f of x, which is the integrand, is an even function, right? So this integral is equal to 2 times the integral 0 to a f of x dx when we have this condition, that is f of x is an even function, right? So the even function is defined by this equation, f of minus x is equal to f of x, right? So here we are going to make use of this property of definite integrals, and apart from this we'll also make use of the definition of mod function. That so now the mod function is defined as mod of p is equal to positive p whenever p is greater than or equal to 0, and mod of p is equal to negative p when p is less than 0, right? So here we are going to make use of these two important concepts. Now see, here we have the integrand mod of sine x. So let us take f of x is equal to mod of sine x. So first we'll prove that this function mod of sine x is an even function. So replacing x by minus x in this function, we have f of minus x is equal to mod of sine of minus x. And from trigonometry we know that sine of minus x is equal to negative of sine x. And here we have mod of negative of sine x, which is equal to mod of sine x, and mod of sine x is equal to f of x. So we have proved that f of minus x is equal to f of x, which suggests that this function is an even function. So now using this property, we can now rewrite this integral I as integral 2 times the limits are from 0 to pi by 6, because if we compare this integral with this one, then the value of a is pi by 6, and f of x is mod of sine x. So we have proved that f of minus x is equal to f of x. So now this integral can be rewritten as 2 times the integral 0 to pi by 6, 0 to a is pi by 6, and here we have a mod of sine x, that is f of x, and here we have dx. So now we have to evaluate this integral. So now we'll define mod of sine x with the help of the definition of modulus function. So mod of sin x can be defined as positive sin x when sin x is greater than or equal to 0, and mod of sin x is equal to negative sin x whenever sin x is less than 0, right? So here we can now make use of the sign convention of sine function in the four quadrants. So here we have the four quadrants. This is 0, pi by 2, pi. Here we have 3 pi by 2, and here we have 2 pi. So here we have the first quadrant, second, third, and fourth, right? And we know that the sine function is positive in the first quadrant and in the second quadrant, and it is negative in the third quadrant and fourth quadrant. So mod of sin x is equal to positive sin x whenever sin x is greater than or equal to 0. So this implies that when x belongs to either the first quadrant or the second quadrant, right? Because in the first and second quadrant the sine function is greater than 0, right? And mod of sin x is equal to negative sin x when sin x is less than 0, and this implies that sin x is less than 0, that is sin x is negative when x belongs to either the third quadrant or fourth quadrant, that is x belonging to the third quadrant or the fourth quadrant. And here the limits of integration vary from 0 to pi by 6, right? So here the limits of integration vary from 0 to pi by 6. So we are in the first quadrant, right? Because pi by 6 is 30 degrees. So the limit of integration, it goes from 0 to pi by 6. We are in the first quadrant, and in the first quadrant sin x is greater than 0. So we'll make use of this part of the definition. So we can now simply write mod of sin x is equal to positive sin x as this x belongs to the first quadrant, right? So we have now 2 times the integral 0 to pi by 6, and mod of sin x is positive sin x, and we have dx, right? Now the integral of sin x is negative of cosine x, and the limits of integration are from 0 to pi by 6. So now we can here substitute the limits, and we'll take the difference. So we can take this negative sign outside, and we have cosine x, and limits are from 0 to pi by 6. So we have minus 2. First we'll take x is equal to pi by 6, and then we'll take x is equal to 0. So here we have 0. So we have minus 2. Cos pi by 6, that is cos 30 degrees, is root 3 over 2, and cosine 0 is 1. So we have minus 2, and we can now write root 3 minus 2 over 2. Now 2 and 2 get cancelled, so we have minus root 3 minus 2, and taking this negative sign inside this bracket. So here we have minus root 3, here we have plus 2. So we can write 2 minus square root of 3. So the value of this integral is given by 2 minus square root of 3. So viewers, this is how with the help of these two concepts and the sign convention of sine function in the four quadrants, we can easily find out the value of this definite integral.